Hi students, good morning. 10th Mathematics, Chapter 7 Mensuration, Sri Vidya Bharati Metric Higher Secondary School, Chakrambalayam, Namakkal. In our last class, we discussed the introduction of right circular cone. So, in our last class, we discussed about the definition of right circular cone. It is generated by the revolution of a right-angled triangle about one of sides containing the right angle as axis. And the next one, the formation of right circular cone. And in this examples of right angle triangle, how it convert to right circular cone, and also to find the L, H, R if any two measurements are given, and also the types of cone. There are three types: oblique, circular, and right circular cone, and derivation of the curved surface area and total surface area of the right circular cone. So if we take a sector of a circle, if we fold the radius of the sector, if we fold radius of the sector, then we get right circular cone. So the sector is folded, we get the right circular cone. In the radius of the sector is slant height of the cone. Radius of the sector is slant height of the cone, and length of the arc is the base circumference of the cone. That is, radius of the sector is equal to radius of the cone, and length of the arc or the arc length is equal to base circumference of the base of the right circular cone. That is, L equal to 2 pi r, perimeter of the base, 2 pi r. And last one, curved surface area of the cone is equal to area of the sector. That's all. So we discuss the curved surface area of the cone obtained from the area of the sector. Here another one formula, how to find the radius of the cone from the sector. If the angle, center angle is given and radius is given, then the radius of the cone is equal to radius of the sector L into theta by 360 degree. That is the to find the radius of the cone. And area of the sector formula is A equal to pi r squared into theta by 360 degree. Here r instead of L. Therefore, curved surface area of the cone equal to area of the sector. Then we simplify. Hence, the curved surface area of cone equal to pi r L square units. And the another two formulas we discussed. And last one, the total surface area of the right circular cone is equal to curved surface area of the cone plus base area of the cone. In the cone, there are only one base, so pi r L plus pi r square. So we take pi r as common, then remaining is L plus R. So total surface area of the cone is pi r into L plus R square units. So these formulas are yesterday we discussed detail. So in this class we discuss the problems based on the right circular cone. So there are 7 sums in this model right circular cone. The first problem in exercise 7.1, exercise 7.1 fourth sum. So look at this sum. A right angled triangle PQR where Q is equal to 90 degree, that is angle Q is 90 degree. So PQR is a right angle triangle, that is Q is 90 degree. Therefore here P, here R. Rotated about QR and PQ. Rotated about QR and PQ. If QR equal to 16 centimeter, PR equal to 20 centimeter, compare the curved surface areas of the right circular cones. So in the sum, which one asked? Compare the curved surface areas of two right circular cones. So that means we want to find the CSA of two cones. That means it rotated about QR and PQ. That means the first one PQ is the axis and the second one QR is axis. PQ is axis and the second one QR is axis. Now in the triangle, right angle triangle PQR, two sides are given, QR and PR. Then PQ is not given, so we are going to find the PQ. So now the solution is, in the right angle triangle PQR, Q equal to 90 degree, PR 20 centimeter, QR is equal to 16 centimeter. By using Pythagoras Theorem, which one is hypotenuse? That is PR. That is a right angle triangle. P, Q is the right angle, that is R. So PR is the hypotenuse. So what is Pythagoras Theorem? The square of the length of the hypotenuse is equal to sum of the square of the other two sides. Then applying the Pythagoras Theorem, PR square equal to PQ square plus QR square. So we apply PR is 20 and QR is 16. We get PQ squared equal to 400 minus 256 is equal to 144. Therefore PQ equal to root 144 equal to 12 centimeter. Therefore PQ is equal to 12 centimeter. So in the right angle triangle PQR, now we know that three sides. Measurement three sides are now here. Then what is the asked in the question? To compare the CSA of two right circular cones, because here two right circular cone means first one, if rotated about the side QR is one type of cone and rotated about the side PQ is another type of cone. That's all. So now first we take PQ as axis, that is PQ as axis, vertical line, that means QR is the base. Then if rotated the side PQ as axis, we rotate the side PR. Here one cone is formed. If rotated PRs to the right to left, we form the cone. here what is h, what is r, what is l. So in the cone height is equal to 12 centimeter. Height is equal to 12 centimeter. And which one is radius? If PQ as axis, that is PQ equal to 12 centimeter, we have to find already. Therefore height is the 12 centimeter. Then what is base? That is radius of the base is 16 centimeter or is 16 centimeter, and slant height is L PR equal to 20 centimeter. So PR is not changed in any way. So in this first question, if rotated PQ about QR and PQ, so now we take PQ as axis, then which one is height, which one is radius, which one is length. Here we want to radius and slant height only. So what is the formula for curved surface area of the cone? It is pi r L square units. Here radius is 16 centimeter, L is 20 centimeter. We apply the formula pi into 16 into 20 equal to 320 pi centimeter square. So this is the first curved surface area of the cone is equal to 320 pi centimeter square. Suppose you have to apply pi is equal to 22 by 7 and we simplify, we get the fraction answer. So 3 in the first sum, if PQ as axis, then curved surface area of the cone is 320 pi centimeter square. So it is enough. And second one, if rotated about QR, that means when QR as axis, QR as axis, when QR as axis, that is here P, Q, R. We write the name in the triangle P, Q, R because Q is the right angle. So we rotated when QR as axis. So QR is axis. So which one is QR? In the sum already they are given QR equal to 16 centimeter. Up. Now QR is the height of the cone. Therefore h equal to 16 centimeter. Then which one is base? Radius. That is 12 centimeter as radius. And slant height is does not change. It is equal to 20 centimeter. So in the comparing these two areas, first one PQ as axis, then PQ is the height of the cone, and second one QR as axis. Here QR 16 centimeter is the height of the cone. Another one is radius. That is very important because this one be used in the sum. In the curved surface area of the cone, we don't need the measurement height. So only we want R and L. So now the curved surface area of the second cone is equal to pi R L square units. Here R is 12 centimeter, L is 20 centimeter. We apply this one, so we get 240 pi centimeter square. So in the question they asked comparing the two curved surface area of the cones formed by rotating the two different sides. So curved surface area of the first cone is 320 pi centimeter square. Curved surface area of the second cone is 240 pi centimeter square. So which one is larger? Therefore curved surface area of the cone when rotated about PQ is larger than that of QR. It is enough, this sentence. Curved surface area of the cone when rotated about PQ is larger. It is omitted or to write full, no problem. So this is the first sum today we discuss. In the first model we just apply the formula, that's all. But in the question there are two CSA will be asked. The first one we take PQ as axis and the second one we take QR as axis. Then to find the curved surface area of two type of cones, we get first one 325 centimeter square, second one 245 centimeter square. So in the sum they asked which one is larger. So which one CSA is larger? That is PQ. Rotated about the side PQ is larger than that of QR. So do you understand the first sum? Okay. So next come to the example 7.5. So first what are the given the sum? In the example 7.5, the radius of the conical tent is 7 meter. So in the sum, one conical tent, that is one of the conical tent. In the conical tent, radius is 7 meter. That is radius. Radius is 7 meter. And height is 24 meter. Which one is height? Join the vertex and center of the base. It is height. So height is how much? 24 meter. And which one is asked? Calculate the length of the canvas used to make the tent if the width of the rectangular canvas is 4 meter. Width of the canvas is 4 meter. See, we want to length of the canvas used to make the tent. So we going to prepare the one circular shape tent. Now we want to use the canvas to make the tent. That means the canvas is to close the conical tent. So how much width, how much length of canvas used? That is asked in the question. Here what is given? That is width of the rectangular canvas is 4 meter. So in the cone the rectangular canvas is used to make the tent. So in the rectangular canvas length is asked and breadth is given. That's all. So first we are going to find the slant height of the cone, because in the conic cone the curved surface area of the cone is pi r l square units. So in the sum they are given radius and height only. Radius and height, but we want L. So what is L? So first we are going to find the slant height of the cone, and then we find the curved surface area, that is how much area of the canvas needed to make the tent, and then find the length of the canvas. So first we discuss the slant height of the cone. So in the conical tent radius is 7 meter, height is 24 meter. So it is the right angle triangle. So that is slant height by using Pythagoras theorem. L equal to root r squared plus h square. So L equal to square root of 625. Taking square root, we get 25 meter. That is slant height. So now we find slant height equal to how much? 25 meter. So now three sides are known. Now we are going to area of the canvas. First one, the curved surface area of the conical tent. That is formula for curved surface area of the conical tent is pi r l square units. Now apply r and l in the formula. Therefore area of the canvas is equal to pi 22 by 7 into radius 7 into l 25. So we get totally 550 meters squared of the area of canvas needed to make the tent. But therefore length of the canvas, in the sum they asked length of the canvas is equal to total area of the canvas is divided by width of the canvas. In the sum width equal to 4 meter. Already in the sums for W equal to 4 meter is given. Therefore length of the canvas equal to area of the canvas divided by width equal to 137.5 meter. That is the length of the canvas is needed. So in the conical tent, total area of the canvas needed 550 meters square. From this we have to find the length of the canvas. It is equal to total area divided by width. It is equal to 137.5 meter. So any doubts? Okay. So do the calculations. You only take rough work. So second one completed, and third sum, example 7.6. It is the simple sum. In the last two sums, area of the cone only we have to find. In this sum, the total surface area of the cone is 704 meter square. So given that TSA is given and radius is 7 centimeter. So in this problem, total surface area of cone equal to total 704 meter square, and also radius is given, that is radius is 7 meter. So which one is asked? Find its slant height. That is they asked slant height is L. They ask L. So if we need L, before we want to find the H, or directly we use this formula TSA and we get the slant height. In the total surface area of the cone, the formula is pi r into L plus r square units. In the formula there are only two measurements, r and L. So we know r, then we have to find the L. That's all. So our total surface area of the cone equal to 704 centimeter square. So in the formula here pi r into L plus r equal to 704. We apply the formula pi 22 by 7 into r, 7 into L we have to find, plus r is 7 equal to 704. Now we cancel the 7 and we simplify. L plus 7 is equal to 22. Come to this left side, it is divided by 722. We simplify it, we get answer 32. Therefore L plus 7 equal to 32. L equal to 32 minus 7. L equal to 32 minus 7 equal to L equal to 25 centimeter. That is slant height of the cone is 25 centimeter. This is the 2 mark. So the fourth sum they asked in 5 mark are separated in 2 marks, and 7.5 also asked in 2 marks. The 7.6 also 2 mark. Next sum in the exercise 7.1, the fifth sum. Here also area is given in the last sum model. So look at the sum. 4 persons live in the conical tent. So in the last sum we want to find the area of the circular tent, area of the conical tent. In the sum, in the conical tent there are 4 persons live whose slant height is 19 centimeter. Whose slant height is 19 centimeter. This is the cone whose slant height is 19 centimeter, and each person required 22 centimeter square of the floor area. So in the base there are 4 persons, so each persons need how much area? 22 centimeter square area. That is only base. That is only, it represents a base. In the base it is separated by 4 parts. So each part required 22 centimeter square. That is called floor area. Floor area means we take the base of the circular cone only. This cone is split into 4 parts. The circular ring is split into 4 parts. Each part required 22, 22, 22. That's all. That means total area of the total floor area of the 4 persons equal to 4 into 22. How much? 88 centimeter square. That means the base area is 88 centimeter square. That is the meaning. So 4 persons live in the conical tent. The area required to live in 1 person equal to 22. So total area of the base is equal to 88 centimeter square, and L is given. L is slant height is 19 centimeter. Then what is asked? So height of the conical tent. Then find the height of the conical tent. So we need h. But in the area of the base is given. So in the area of the base there is only radius is given and L is given. So first we have to find the radius of the cone. Next we are going to find the height of the tent. So in the base area is equal to 88 centimeter square. So what is the formula for area of the base? Area of the base is equal to area of the circular base equal to pi r squared. So pi r squared equal to 88 centimeter square. We apply pi as 22 by 2. We get r squared equal to 28. So r equal to square root of 28. So it is a third. In this third we multiply product of two numbers, 7 into 4. We taking 4 as root. Therefore radius equal to 2 root 7 centimeter. That is the radius of the conical tent equal to 2 root 7 centimeter. So already L is given and R is we have to find. Then find the height of the conical tent. H equal to root L squared minus R squared. So root L squared is L squared is 19 centimeter square. R square is radius R equal to 2 root 7 centimeter. here r squared is directly we put 28, that is root 2 root 7 whole square. R squared means 2 root 7 whole square. 2 squared is 4 into root 7, square of the root 7 is 7, so 7 into 4 28, that is directly we use r squared equal to 28. L squared is 19 square, so we simplify square root of 333. So in 8th standard to find the square root, so now taking square root of 333, we get the answer 18.246 and etc. The last two decimal places, therefore height of the cone is approximately 18.25 centimeter. So this is the simple sum, but the radius is in the irrational number and the height also in the fraction, so calculation is very difficult. So take the important of the sum. So in the sum, slant height is given, and in the circular base there are 4 persons living. One per each person required 22 centimeter squared of the floor area. Then total floor area is 4 into 22, 88. Then pi r squared equal to 88. Now find r equal to, that is here also r squared is equal to 28, that is r equal to 2 root 7 centimeter. So without finding r, we go to use the r square directly into the formula, and h equal to root L squared minus r squared equal to 18.246, it is approximately 18.25 centimeter. Okay, any doubts? Okay, next one, important 5 mark. So in this sum, a girl wishes to prepare birthday cakes in the form of a right circular cone for her birthday party using a sheet of paper whose area is 5720 centimeters square. How many caps can be made with the radius 5 centimeter and the height is 12 centimeter? So in this sum, which one is given? Given conical cap, radius is 5 centimeter, height is 12 centimeter. So in the CAC or TAC of the cone, we need only radius and slant height, but height is given, therefore we are going to find at least any one of the another one. So we have to find radius or slant height. Here radius is given, so now we are going to find the slant height of the cone, then only which one asked in the sums. So radius is equal to 5 centimeter, height is equal to 12 centimeter, therefore slant height of the cone L equal to root r squared plus, sorry that is a mistake, L squared equal to L equal to root r squared plus h squared. So take the correction, or write h squared instead of r square. So slant height L equal to root r squared plus h squared, is equal to 5 square plus 12 square equal to root 169, that is equal to 13 centimeter. That is the slant height of the right circular cone. So a girl to prepare right circular cone birthday caps using the sheet of total area, how much? 5720 centimeter square. So what is the asked in the question? How many caps we prepared? How many caps can be made by using this area? Here number of caps is equal to total area of the paper, that is numerator, is divided by curved surface area of one cap. So how much cap can be made from the total area of the sheet? Therefore number of caps equal to total area is divided by curved surface area of one cap. That is total area is 5720 divided by curved surface area of cone is pi r L. So 5720 divided by pi into r into L. So 7 is going to the numerator. So we simplify it, we get the answer 28 caps. So you do the calculation how it is simplified and we get the answer 28 caps in the rough work. So this is one important 5 mark. So in the sum, in the conical cap, radius and height is given. We want to find L equal to 13 centimeter. And how many caps means total area is given, and number of caps equal to total area divided by curved surface area of the one cap. So number of caps equal to 28 caps. So and next 5 mark. So next sum, the 7th sum, the ratio of the radii of two right circular cones of same height 1:3. Find the ratio of their curved surface area when the height of each cone is 3 times the radius of the smaller cone. So in the question, the ratio of the radii of two right circular cones of same height, that is 1:3 is the radii of two, ratio of the radii of two right circular cones, that is r1 is the radius of the first cone, r2 is the radius of the second cone, then r1 is to r2 is equal to 1:3, that is given. And also, and given height of each cone is 3 times the radius of the cone, that means h equal to 3 times the radius of the each cone, that is h equal to 3 times the radius, that means h equal to 3r. But in two cones, we take the height of the first cone is h1 and the height of the second cone is h2. But in the first line, they asked same height. In two cones is same height, that means h1 equal to h2. It is equal to 3 times its radius, that means 3r. Therefore, what is asked in the question? Therefore, to find the ratio of their curved surface area, that means curved surface area of first cone divided by curved surface area of second cone, that is asked in the question. So what is the formula for curved surface area of cone is pi r L. In the first cone pi r1 L1 and second cone pi r2 L2, that's all. So we need r and L, but in the sum they given r and h in the ratios. So now the answer is, for two cones r1 is to r2 is equal to 1:3, and r1 is, that is r1 equal to 1x and r2 equal to 3x. So we have already told r1 by r2 equal to 1/3 means r1 is not equal to 1, r2 is not equal to 3, because this is the division, that is 1/3. That means we simplify the common factor, we reduce the common factor, then only we get answer 1/3. That means r1 equal to, that is 1x and r2 is 3x. So that means r1 equal to 1 centimeter, r2 equal to 3 centimeter is not correct. So let r1 equal to 1x and r2 equal to 3x. And now to find h1 and h2. So h equal to 3 times its radius, That means h1 equal to 3 times into radius of the first cone. So h1 equal to height of the first cone equal to 3 times the radius of the first cone. But h1 equal to 3 r1. So r1 is equal to x. Therefore h1 equal to 3x. And h2 height of the second cone is 3 times its radius. Now h2 equal to 3 into r1. So h1 equal to 3 into r1 equal to x. So h2 is also 3x. So height of the first cone is 3x, height of the second cone is 3x. So in the sum already they told the two cones are same height. That means h1 equal to h2 equal to 3x. So now we have to find the L1 and L2. So we have already known R1, R2, H1, H2. These measurements are known. So from this we have to find L1 and L2. L1 equal to square root of h1 squared plus r1 squared. So h1 is 3x, h1 squared is 9x squared, r1 is x. Suppose r1 equal to x, therefore 9x squared plus x squared equal to root 10x square. Now taking root 10 into taking square root of x squared x. Therefore h1 L1 equal to root 10 into x, not root 10x. So root 10 into x. And the second one, the slant height of the second cone, L2 equal to root h2 square plus r2 square. Again h2 is 3x, so h2 square equal to 9x squared, and r2 square, r2 is 3x, r2 is 3x. Therefore 9x square plus 9x squared equal to how much? Square root of 18x square. So split 18 is equal to square root of 9 into 2 into x square. So 9 taking root 9 is 3, 2 is not a perfect square number, so 3 root 2, and taking root in x squared we get x. So 3 root 2 into x. This is the slant height of the second cone. So slant height of the first cone is root 10x, slant height of the second cone is 3 root 2 into x. In these two, x is separated. So now L1 and L2 are we have to find already. So now we are going to find the ratio of the curved surface area of two cones equal to CSA of cone 1 divided by CSA of cone 2 by applying the formula pi r1 L1 divided by pi r2 L2. So you are applying this, pi into r1 is x and L1 is root 10x divided by curved surface area of cone 2, pi into r2 is 3x and L2 is 3 root 2x. We simplify it, taking pi as cancel, and we simplify x and x and x and x, then simplify root 2 and root 2, we get the answer root 5 by 9. So it's the ratio form. Therefore ratio of the curved surface area equal to root 5 is to 9. So it is the very easy one, but you understand only, then this is very easy sum. So in the sum which are given, first one, the radius of the two cones r1 is to r2 is equal to 1 is to 3. That means r1 equal to 3x, r2 equal to 3x, and the heights are equal. That means h1 equal to h2. So h is equal to 3 times its radius. That means h1 equal to 3 r1, that is 3x. h2 equal to 3 r1, h2 equal to 3x. It is the 3 times the radius of the smaller cones. So here you have only one doubt. H1 is equal to 3 into R1. Then why H2 equal to 3 into R1? Because in the ratio R1 is 1x, R2 is 3x. So which radius is smaller? R1 is smaller. In the sum, height of each cone is 3 times the radius of the smaller cone. So we use H1 equal to 3 into R1 and H2 also 3 into R1 because R1 is the smaller cone. Therefore, L1 and L2 we have to find. L1 equal to root 10x, L2 equal to 3 root 2x. Ratio of the two cones equal to CSA 1 by CSA 2. Applying the formula and simplify, we get the answer root 5 is to 9. Okay, any doubts? Okay students, next last sum in the example 7.7. In the example 7.7, from a solid cylinder whose height is 2.4 centimeter and diameter is 1.4 centimeter, conical cavity of the same height and base is hollowed out. Hollowed out means they cut the cone and taking. Then what is asked? Total surface area of the remaining solid. That means in the cylinder, they cut the conical shape and it curved out from the cylinder. Conical shape is cut into the cylinder. Then find the radius, find the area, total surface area of the remaining solid. So find the total surface area. Find the total surface area of the remaining solid. That means, what is meaning? ஒரு சிலிண்டரில் இருந்து ஒரு கோனை என்ன பண்ணுறாங்க, கட் பண்ணி வெளியில் எடுத்துடுறாங்க. மீதி இருக்கக்கூடிய ரிமைனிங் போர்ஷனுக்கு மட்டும் டோட்டல் சர்ஃபேஸ் ஏரியான்னு கேட்குறாங்க. நாட் சர்ஃபேஸ் ஏரியா ஹியர், curved surface area, here it is total surface area. Okay, do you understand? So from a cylinder, in the cylinder height is given and diameter is given. Height is 2.4 centimeter and diameter is 1.4, that is radius is equal to 0.7 centimeter. D equal to 1.4 divided by 2 equal to 0.7 centimeter. Therefore, to find the area of the total surface area of the remaining solid. So what is the total surface area of the remaining solid? So total surface area of the remaining solid equal to curved surface area of the cylinder. Total surface area of the remaining solid equal to first one, curved surface area of the cylinder plus curved surface area of the cone, that is this area. It is cut from the cylinder but remaining solid is in the conical shape in the topper side. Top in the cylinder, top sides is open in the shape of right circular cone. So CS of the cone, and in the sum they asked total surface area. Therefore in the cylinder there is only one base. This base is curved out from the cylinder, so there is only one base, that is plus area of the bottom. Area of the bottom is circular in shape. So therefore total surface area of the remaining solid equal to curved surface area of cylinder plus curved surface area of the cone plus area of the base. So in the curved surface area cylinder we need R and H, they are given in the problem, and curved surface area of cone we need the R and L. So r is given, that is radius is same for the cylinder and cone. Now we are going to find the slant height of the cone. So slant height of the cone L equal to r squared plus h square. R is 0.7, so r squared 0.49 and h 2.4, therefore h squared 5.76. so we adding, we get 6.25, square root of 6.25, that is equal to 2.5 centimeter square. So 25 into 25 equal to 625, that is 6.25, 2 digit, so in a single digit taking point, therefore the square root of 6.25 is 2.5 centimeter, that is L equal to 2.5 centimeter. So now therefore the total surface area of the remaining solid equal to, there are some of the three parts. First one, the outside part is curved surface area of the cylinder, inner part is curved surface area of the cone, the base area is area of the part. So applying the formula, curved surface area of the cone, what is the formula? So in this topic is we discuss the cylinder, cone, but the cylinder formula can be used in this exercise. So first one, curved surface area of the cylinder is 2 pi r h plus curved surface area of the cone pi r l plus area of the bottom pi r square. So from these three we are taking pi r as common, so remaining is 2h plus in this remaining is l plus third one remaining is r. So pi r into 2h plus l plus r, therefore equal to pi 22/7 into r is 0.7, 2 into h is 2.4 plus l is 2.5 plus r is 0.7. We simplify, we get answer is 7.6 meter square. So we taking the calculations, you do the rough work in this example sum. The answer is 17.6 meter square. Here one mistake in our book. In the sum, height is in centimeter and diameter also in centimeter. So the answer must be in centimeter. Here meter square is there, so we write 17.6 centimeter square, 17.6 centimeter square. So we use L equal to 2.5 centimeter, so all measurement in the same unit, centimeter. So in the answer we use 17.6 centimeter square. So take the all sums in to write the notes. So now we discuss there are 7 sums. Example 7.7, exam exercise 7 and 6. These 3 sums is 5 mark and 5, 7.6, 7.5 and 4 and 7.5 2 marks, and 7.4th sum asked 2 mark or 5 mark. Okay students, so from this class we discuss the curved surface area of the right circular cone based problems. So this class right circular cone based sums are completed. So in our next class we discuss the another solid spheres such as hemisphere and sphere. Okay students, thank you.